welcome to Flanigan's Ecologic. I'm your host, Ted Flanigan, and I'm delighted to welcome Matt Harper back to the podcast. We spoke in June of 2022, episode number 67. This is episode number 265.
Well,
That episode covers a lot of ground on the value of vanadium-flow batteries, which is Matt's business. Their 30-year lifetimes, unlimited cycling. They can discharge for 8 to 10 hours a day. They have zero fire risk. They're modular. They can stack, and the end result is that his batteries have the lowest life cycle megawatt hour delivered costs. So, very impressive stuff. I always call on Matt when I've got questions about batteries. Thank you for that, Matt, and welcome to the podcast.
it's great to be back, Ted.
Great. Well, things have really progressed for you. You told me the other day you have now 190 megawatt hours of batteries installed and in construction all over the world. Is that right?
Yep, that's right. You got it. We've been, since we spoke. I mean, that number was probably more like 10 megawatt hours, maybe 15 back when we spoke in 2022. So it's been, phenomenal ride over the last couple of years, getting these batteries deployed into more applications, into different regions, doing different jobs on the electric grid and off the electric grid, I guess. And ultimately just in much larger numbers. We've learned a ton about where these batteries make sense, frankly, where they don't in some instances.
Yeah.
And have done a lot of work towards getting those things to be as dependable, reliable, and as low cost as possible as part of that journey.
And you are now the president of Invinity Energy Systems.
That's correct.
When I interviewed you before, I think you were the chief technology officer.
Chief commercial officer, I think, at the time.
Chief commercial. And Matt, I'm interested that you rate your batteries in their energy, in the megawatt hours, as opposed to the capacity, the megawatts. And I presume that's because you're a long duration energy battery.
Yeah, and that's definitely part of it. Typically what we found is that most people are looking to trade our batteries, right? They're looking for how many megawatt hours they can, for example, absorb out of a solar PV plant over the course of a day, and then deploy those megawatt hours back into the grid at a time when they're a lot more valuable. The most straightforward version of the value prop for that is how many megawatt hours you've traded and at what kind of spread. Yeah. And so that's how we think most commonly about the size of those batteries. Now, that's not always the case. We've got a lot of projects that are being deployed to what we think of as more capacity focused purposes. So, building the megawatts on the electric grid that people are going to need to, make sure when you flip your light switch, the lights go on. And so, there are definitely applications where people think primarily in terms of megawatts, but we can be a little bit flexible in how we describe them, depending on what people are trying to do with the batteries, how they're trying to make money with them.
Probably a lot of our listeners are used to demand clipping. A battery, a lithium-ion battery, discharges for an hour or two to avoid the peak period. Yep. And yours it's really a different strategy. But I want to get back into your installations, because I think I read, or you told me, 96 installations, 17 countries. You have 81 patents. You've been in business for 17 years. Projects in Canada, Australia, the UK, Europe, and Hungary. It's fantastic.
Yeah, it's all over the place. It's pretty exciting. Certainly from the scrappy little startup we were not that many years ago. Yeah. It's been a step change going forward.
Well, and I want to just thank you for jumping on, because I know that your plans change. You're literally this afternoon or this evening, you're flying off to India, right?
That's right.
Halfway around the world.
It's true. We had a relationship with a company in India that we've been developing over about the last almost the last year or so. India is a phenomenal opportunity for energy storage. They've got great solar resource. There's a big push to start manufacturing a lot of that solar power generating capacity in country. At the same time, the imperative to get off of coal is getting bigger and bigger. and it's very much a coal-fired grid at this stage. It's a country with some of the most serious environmental challenges in the world. It's one of those countries that has the most potential upside in terms of the future growth of the electric grid, that they deal with things like electrification and air conditioning and all those sorts of things. If that pathway for electrification over the next decade in India is going to be both economically viable and ecologically viable, it's got to be a combination of renewables plus batteries that are going to get the job done. And so we're really eager to be part of that.
Yeah, it's so encouraging, Matt. I remember years ago hearing that no matter what we do in North America, the Chinese and India, they're going to be continuing to produce coal, and what we are going to do is irrelevant. And now you look what's happening in China. Now you're talking about India. I wanted to ask you about Hungary, because you told me the other day that Hungary is a hotbed for battery storage, and I think this is primarily the grid scale storage, right? And tying into the grid and leveling out the load profile. Is that right?
Yeah, and there's two different parts to it. There's a very broad program that the Hungarian grid operator and the government behind them have been supportive of, to get batteries writ large onto the electric grid for all of the kind of capacity management, power quality management, and energy supply reasons that the rest of the world has looked at batteries. The thing that they've done a little bit differently is that they, I think, like us, see that in the immediate term, lithium-ion batteries and some of these other technologies that are good for filling those immediate gaps in grid capacity are available and can do the job. But when we look out to sort of the grid of the 2050s, we need to have assets serving the electric grid that are not being installed and operated for 10, 12, 15 years, but rather operating on the grid for decades. And so they carved out a portion of that storage program for batteries that had, that were capable and had proven to be capable of providing decades worth of service on the electric grid. That eliminated lithium-ion from the running, and opened the door for companies like ours, providing much more durable solutions to step in and provide those things. This is, sorry, one last thing. This is me getting a little bit policy wonkish, but I think the really cool thing that they did is that they made sure that that the mechanism for those longer term, longer service lives, was not just saying like, go do it. What they did is they put that back to back with offtake commitments, so contracted revenue commitments that have that same kind of durability. And so that's really nice in our view, because it means that that's not just some regulator saying that something needs to be done. It's the market that these batteries are selling into being built over a long period of time, which allows sort of that continuous optimization and maturation of storage capabilities in the long run.
Now, what does that mean that the off-taker has a long-term responsibility? In other words, somebody who purchases one of your batteries has a responsibility to operate that battery for a long period of time?
Yeah, that's exactly. They've got both the responsibility to operate it, but they've also got the revenue streams locked and loaded. So, provided that they continue to, provide the same number of megawatts of availability and megawatt hours worth of capacity, and do that for the next, in year 20, they already know what their revenue stream from that is going to be, and that's really helpful in terms of financing some of these longer term projects.
Am I right when in the opening I said 30 years? Is that about and then what happens? As you've described it to me before, a flow battery has got two tanks, and the electrolyte, the vanadium, is flowing, redox is flowing back and forth, and you've got pumps that are moving them back and forth. I think you told me at one point you could actually add more vanadium if you needed to top off the tanks.
Yeah, and what we found over the last couple of years is that the amount of vanadium that we put in on day one really is the total amount of material you're ever going to need in the battery over its service life. what we need to be able to maintain the capacity in the system is, it's like any system with moving parts, right? You're going to have to replace pumps. You're going to have to replace, some of the power supplies, these sorts of things. But that starts to look a lot more like a maintenance project that you would do on a car, for example, than something that requires the wholesale replacement of the entire battery within that time frame. And again, why that's valuable is because it means that, when you get that asset installed and operational, it's going to perform the same way over decades, right? Yeah, you're going to have to replace a fan here or there or some air filters. But in terms of the capacity, the work done, the permitting, the financing, the insurance wraps that stand alongside these batteries, you've locked and loaded it on day one, and it becomes a durable asset that you can just use over a very long period of time.
Possibly longer than 30 years?
Possibly, yep. And we use 30 years as the life because our engineering teams are pointing to that as sort of the very, very earliest point at which some of the a larger number of the components may need to start to be replaced.
Right.
Frankly, it's probably a lot longer. But at that stage, you're probably going to be making, as you would with, say, a gas turbine, you'll be looking at, new technologies, what's changed over time, and whether there are more efficient, better optimized solutions that you can, just on a purely economic basis, decide to make a replacement for.
Let's talk about the world supply of vanadium. Where is it? Is it abundant? I think you told me it is very abundant.
The stuff is absolutely everywhere. It's the 13th most common element, metallic element in the Earth's crust. It's more common than copper, more common than nickel. Most of the world's vanadium, something like 90% of it, today goes into strengthening other metals. So rebar often has a lot of vanadium built into it. Anyone who's familiar with some of the high strength titanium alloys that go into, for example, high-end bike parts, they often have some vanadium alloyed with them. But by and large, it's it's industries that have not grown significantly over the last 30, 40, 50 years. So the world supply of vanadium comes from all over the place. We buy it from South America, from South Africa, from China, from Japan. It's really, really widely available.
I'm glad you were able to slip bicycles in there, because I know you were an avid bicyclist before. Strengthening your frame.
Yep, yeah, that's exactly it. Yeah. Not as much titanium. Actually, I do still have a titanium frame bike. Yeah, it's beautiful. It's got to be about 20 years old now, but it's lovely. Fillet brace frame. It's incredible. So the one thing I was just going to add on the vanadium side, though, is one of the things we've been exploring over the last year or two is that there's a tremendous amount of vanadium available in waste stockpiles. You're probably aware that about 3 or 4 years ago, there was a new standard in offshore marine fuels that came into play. That was a low sulfur standard, trying to get this, the SOx out of the emissions from, offshore big freighter ships and that sort of thing. Well, when you take the sulfur out of heavy crude, what comes with it is vanadium. And so the waste byproduct from, this refining process has, hundreds of millions of pounds of this vanadium starting to accumulate all over the world. What's exciting to us is that we're starting to see a couple of examples in the Gulf and in Europe where companies are looking at extracting that vanadium along with a couple of closely related metals that come along with it from those waste streams. And, from our perspective, that could conceivably be, an enormous amount of material for us in a way that doesn't require digging new holes in the ground to get the vanadium.
That is really intriguing. What other countries are you excited about? I think Australia is one of your another hotbed of activity for you.
Yeah, for sure. It's look, it's been a hotbed for renewables and for storage in general for some time. We've got one of our largest currently operating projects there. It's been operating for about 2 years now. Basically the situation in South Australia, which is the state where it's installed. They have so much solar PV generating capacity that I don't know what the number is, but hundreds of days per year they've got negative electricity prices in the middle of the day, right? So there's no incremental value to delivering solar PV power onto the grid. What our battery does is it takes that low to negative value electricity, absorbs it directly off the solar panels without even going onto the AC bus on site. It takes it right off of the DC bus, charges the batteries, and then delivers it back onto the grid in the evening time when not only is it much more in demand, but it's a lot more valuable. I was really impressed. I went to Australia for the first time about 18 months ago, and I really think they're going to be the first net zero grid in the world. They've got the resource in terms of sun and wind. They've got the some of the right structures in place in terms of how their grid is being operated, and they are absolutely dead set on making it happen. So I think we're going to see really good things out of Australia in the pretty immediate term.
That's exciting. And then they're also sending power all the way to Singapore with this huge undersea cable.
It's called Sun Cable. Is that the name of the project?
Like that. It's just very impressive.
It's pretty incredible. Yeah.
Another project that you mentioned, I wanted to get a little update on, was in Scotland, where they've got some tidal power, and then they've got a plant where they're electrolyzing water to create hydrogen.
That's right. Yep.
And they want that plant to be operating 24/7, and of course the tidal power is not available 24/7. And your batteries are buffering that, I guess.
No, it's absolutely true. I mean, our sort of our North Star for what we want our business to be able to do in general is really to generate clean renewable baseload, right? How do you take solar power and deliver it back onto the grid when it's not bright out, so that you get 24-hour clean power? Doing that with solar is great because you do a one long duration discharge per day. You charge over, say 8 to 14 hours, and then you discharge back over whatever the balance of the day is. In tidal, it's an even more aggressive duty cycle because by the time you think about 2 tide cycles per day, but then the power actually fluctuates with both the ebb and the flow. So you've got 4 cycles up and down of what that turbine is generating over the course of the day. To take that and turn it into steady, clean baseload power, you're cycling your battery 4 times a day. That's an absolutely punishing duty cycle. To do 4 full charge discharge cycles a day and to do that 24 hours a day for decades on end is an absolutely punishing way to treat a battery. And it's one that we do really well, right? Because we don't have any degradation or any wear and tear based on the cycle life of the system. So a really good application for us, and we're eager to see what they're able to do with it.
Any other really, really cool projects we should be hitting on here? I mean, there's probably dozens, but that one is so colorful. Any others like that?
Yeah, well, look, I mean, closer to home, the project that we're just bringing online right now in SoCal is with the Viejas Resort and Casino just outside of San Diego. They had this incredible vision for what they wanted to do with their power supply at that site. They wanted really to take this pretty good sized destination resort and achieve full energy sovereignty with that thing. So being able to self-generate their own electricity, being able to take it off grid at times when grid demand was at its absolute peak, and then use that to run that facility 24/7 was just an incredible challenge, and one that we really resonated with when we first heard about it, and one that we've really been thrilled to be part of as we've built it out over the last couple of years.
And a lithium battery just wouldn't do the job there, right? I mean, it would be much more expensive and just not intended.
You'd end up having to overbuild it a lot more, right?
Yeah.
I mean, because you've got at that site, you've got the combination of a lot of power coming in from the solar PV. Plus, they've also got one of the world's largest EV charging stations. They've got 400 charging points at that facility. Wow. And so, you've got this incredible duty cycle where, you're charging in the middle of the day, you're discharging to provide power to the facility overnight. And then in between, you've got, these cycles where everyone shows up at once and plugs their cars in, and, everyone shows up after work, whatever it is. And you get these huge spikes in the on-site load. It's incredibly challenging duty cycle, and again, one that, because we don't really care what the cycle profile looks like, because we're not going to degrade based on the cycle life. We're really happy to see that kind of duty cycle is something that's really valuable to them and really in the realm of possibility for us.
I'm glad you're doing some projects in North America. It was starting to sound like you're so busy. I know Invinity was a UK-based company, and you're doing projects all over the world. It's nice to hear that there's some local stuff, or local to me anyway, in SoCal. I know you're based up in Vancouver. Are the units still 30 kW, or do you have larger units?
No, our basic form factor right now is a 350 kilowatt hour block. We're going to be stretching that significantly over the next year, trying to get up to the point where we can do single strings in the megawatt hours, and really that's just the recognition of where our product maturity has gone, and then where sort of the sweet spot of the market is from our perspective.
So those early units that I saw up in, I guess Fremont or somewhere, those were like 30 kW, weren't they?
30 kWh, yeah.
30 kWh. So you're 10 times as large.
Yeah, over 10 times now, and sort of pushing beyond that in the near future. Yeah, that's exactly right. And actually, look, it was actually really good for us to have a relatively small form factor, because the ones you saw were sort of individual building blocks.
Yeah.
What we did as kind of the next stage after that is we took those individual blocks and we packaged them inside, what looked like a 20-foot shipping container, put 6 of those in every one of those blocks. So, every one of those became a 220 kilowatt hour, building block for projects. But what that means is that, think about those individual 30 kilowatt hour modules. Like, we built, shipped, and now have operational something like 2,000 of those individual batteries. That's more flow batteries than has been built by the rest of the flow battery industry ever. It's a huge number of those absolutely standardized modules. And what that gives us is not only, the ability to go to our suppliers and go to our manufacturing plant and really drive sort of low cost and high quality through all of the manufacturing cycle, but it gives us an incredible data set coming back into our company in terms of how those modules are actually operating.
Right.
And to be able to look at those and really understand how they're performing, how they're behaving over time, what maintenance we might need to do over the next 6 to 12 months. That's a tremendous value to us, having all of those absolutely identical modules providing feedback in our direction.
Interesting. Now you're expanding manufacturing in the United States. I was wondering, is that related to tax credit rules, or are you trying to avoid tariffs, or all of the above, or what's the strategy?
Yeah, and look, we're still in a planning phase on how to get that done. In part, it's related to the tax credits, specifically the production tax credits that accrue to battery manufacturers who are making that investment in manufacturing in the U.S., in building jobs and building industrial capacity and building supply chains domestically. Mm-hmm. The other part of it, of course, is the tax credits that are available to our customers that are higher when we're able to meet certain thresholds for domestic content within the projects. Again, refer back to what we were saying earlier about the availability of vanadium, right? There are good sources of the stuff available in the U.S., and that's a big part of the total cost of the product. So it's comparatively straightforward for us to build a domestic supply chain, and we're eager to start delivering product out of that, hopefully in the not too distant future.
Well, that's great. And then FEOC, I love that term. What is it? Foreign entities of concern. So you, in order to get that PTC, or for your customers to get the tax credits, they have to show domestic content. You can't be bringing in supplies or equipment from countries that are of concern to the United States, right?
Yeah, absolutely. And the nice thing, so you mentioned earlier sort of the merger that we did about 6 years ago with a company based over in the UK. Yeah. Through that merger, we became listed on the London Stock Exchange. And one of the stipulations inside the FIAC rules is if you're a foreign entity, but yet publicly traded on a de facto public a real public market, that you sort of automatically qualify within those stipulations. So it's actually really easy for our customers. They don't have to start to look, okay, well, who really owns this thing? Who's the true beneficial owner? No, we can just say, look, ticker symbol is IES. You know who we are. You can see all of our regulatory disclosures. It becomes very easy to actually have some of those FIAC exemptions apply to us.
Yeah, great. Help me out. I think this is an easy question, but I see from the website that you have something called Endurium and Endurium Enterprise. What are those?
So Endurium is the next generation product we launched about 16 months ago. It is that we talked about those individual modules that you'd seen a little while ago. We talked about building 6 of those into a shipping container. Endurium was taking that same 20-foot shipping container form factor and turning it into a single module all by itself. So single set of pumps, single set of tanks, single set of cell stacks, which is where the charge and discharge actually happens. All of that is now built into that single 20-foot block. That's the Endurium building block. When we talk about Endurium, well, technically what we do with every one of those is, they operate at about 300 volts, and we stick 4 of those in a string together to get up to the roughly 1200 volts nominal, where most inverters operate most effectively. The challenge is, though, that that becomes a pretty big battery to have on site, especially if you're a relatively small or small to medium scale commercial or industrial facility. So what we developed and launched about 6 months ago is what we call Endurium Enterprise, which is basically a version of that same platform, but that's optimized for commercial and industrial use behind the meter. So not looking at projects that are in the tens to hundreds of megawatt hours, but looking at projects that are in the sort of small single-digit megawatt hours, for really for regulating the power flow onto commercial and industrial sites, and ultimately saving those electricity users money on their electricity bills.
Right. So now somebody buys one of your batteries. Let's say it's a manufacturing facility. They buy them. They don't lease them, right? Or they're not buying kilowatt hours out of them. Is that right? Who maintains them, I guess, is my question.
So it really depends on the jurisdiction. In California and sort of in the UK and some of the other jurisdictions where we operate, day in and day out, we do that work ourselves. I'd say more generally, usually what we try and do is contract for either a local service provider, or ideally, if it's a large solar or wind plant, whoever is already doing the maintenance on that facility, to add our battery into sort of the basket of suites that they're providing on site. You can imagine that just getting trucks rolled out to the desert and boots on the ground is a big part of the cost of servicing a lot of those projects. And so to the degree that we can kind of pile in with everyone else operating on that particular site and contract for that work to be done on our behalf, it's really beneficial.
Last couple questions. We talked a little bit about Australia becoming what you thought might be the first big, large country being net zero, but I think you introduced me to this term zero. What is the difference between net zero and zero? I guess
I might have just made that up.
Really?
I mean, net zero, I think is for example, you're still going to keep burning some gas, but you're going to plant a whole lot of trees that on balance is going to get you at zero. Zero is you're just not burning gas. I think as we move into sort of the second half of this century, that's going to become a bigger question. It's not going to be so much, are you going to be at net zero? It's going to be, are you, actually hitting zero emissions? And are you going to start to roll back the clock, right? At some point we're going to want to start reabsorbing all of this CO2 that we've put out into the atmosphere. And there are some very interesting emerging technologies, carbon capture and whatnot, that might be part of that. There are some very interesting old technologies, planting forests, for example, that could be an interesting part of that. So, I'm curious to see how that conversation evolves. But certainly that thinking about that 0-0 or that sort of carbon negative world
Yeah.
is going to be pretty exciting.
They're really interesting. I love it. It sounds a little bit like a soda, doesn't it? 0-0. I mean, it's
0.
too good to be true.
It's like Coke 0-0, and then
But yeah, 24/7 carbon-free power, right? I mean, it's
Totally.
basically what we're talking about. Well, what's next for Invinity? Is it just Matt Harper and team to continue taking their vitamins and carry on, or are there any other plans?
No, well, I mean, look, I think the next step for us is scale, right?
Yeah.
We are looking at some projects. There's a lot of projects all over the world that are focused on longer duration storage, which is kind of broadly one of the categories that we fit well into.
Yeah.
Where there have been relatively sort of moderately sized long duration, or they call it LDES projects,
Yeah.
that have been built. But the next stage of those are like in the hundreds of megawatt hours and above. There's a program in the UK, for example, called Cap and Floor, which is how the UK electricity regulator is promoting some of these projects to get built, to bring that longer duration capacity onto the grid. We were thrilled to have had something like 16 gigawatt hours worth of our batteries sort of moved to the short list on that in that program. Now, there's no way we're going to get all of those built. That'd be
big numbers.
Those are big numbers. But certainly, like even a small subset of that would be a huge step forward in terms of proving the work that our batteries can do for electric grids all around the world.
Yeah. Hey, congratulations on the growth of the Invinity and your role there. And again, thank you so much for being part of the podcast today.
Yeah, always happy to do it. I think I'm looking forward to coming back somewhere in the 460s. We did 16, then we did 260, now we're at 460, something like that. So
I'll take you up on that.
Seeing you then.
I will take you up on that.
Okay, it's a deal.
Matt.
Thanks, Ted.
That's it. Thanks for listening to Flanigan's Eco Logic. We'll see you next time.